So here's some of the equipment that we're going to be using for experiment 6. So before I talk about how to do the experiment itself, I've got just some housekeeping issues to talk about. So first of all, the way in which we get our theoretical accelerations in this experiment is you do free body diagrams for various parts of the apparatus and then find a force equation. Some students find that really tricky to figure out, so on the website I have put up an optional video you can watch that gives you hints on how to do the prelab. So if you're having trouble with that, go and watch the optional video. Second thing I'll talk about is that this is one experiment where it's possible to finish early. So not everybody does, but if you're on the ball, I've had students finish in as little as an hour. So it's something to work towards if you want to. Third thing I'll mention is in this first trial that we look at in particular, it's very sensitive to you having not leveled the track carefully. So do this as well as you can, or you might have a lot of trouble getting good agreement between your values. Another thing that relates to this first trial is we're going to be dangling this hanging mass over the pulley and having it attached to the cart. The perfect length for your string, this is not super important, but the perfect length is that when the cart is sitting against the end stop here, that hanging mass is just touching the floor. So if it's exactly that height, it tends to give you a little less, fewer headaches when you're doing the experiment. So you can adjust the length of your string if you need to. Just make sure that it's a knot we can untie easily. And the last thing I'll tell you about is actually the first part of the experiment. And that is that you need to weigh 3 things. So there's a table in your manual and 3 things that you need to weigh. So the first thing you weigh is the cart with all its added masses set on it. So you just weigh it as one big chunk like this. Second thing you need to weigh is the hanging mass. And I know it says 50 grams on here, but take it to the scale and weigh it. Get an exact value. And the third thing you need to weigh is everything together. So you put the hanging mass on the cart with its added masses, weigh everything as one big chunk like this. The electronic scale that you use to weigh everything is sitting on the side counter of the lab, and the uncertainty for it should be either on the scale or near it. If you can't find it, ask your lab instructor to tell you what the uncertainty of the electronic balance is so that you know what the uncertainty of your masses are. So now we're ready to talk about how to actually take data for this experiment. So what we're going to do is we're going to get an experimental acceleration for this cart. We're also going to calculate a theoretical acceleration. We actually do that first. So to get the theoretical acceleration of this guy, we get the free body diagram for the cart on the track and also for this hanging mass, which is going to be accelerating it. And we use those 2 equations to get our force equation for the cart and to solve for its acceleration. So you'll start, first of all, by getting your theoretical acceleration value for this. Then you're ready to actually get an experimental value. So this is going to be very similar to what you've seen in a previous experiment, where we've got a hanging mass on a string, and we just dangle it over the pulley and attach it to our cart. And then we're going to use the acceleration program as normal and just release this guy, capture that motion, and once we've got it, we can then fit a straight line through our VT graph and get the acceleration of the cart. And that value should agree with your theoretical value within uncertainty. Now in the second part of the experiment, we're going to accelerate this cart in a completely different way. So get rid of this string and the mass hanger. You don't need that at all. I also recommend that you take these masses off of the cart. By rights, you'd get exactly the same value if you left it on. It just makes things much more violent and noisy. So I recommend you take the masses off. So what is going to accelerate this cart now is the fact that we're going to tilt our track. So you grab your brick and you fit it underneath the legs of this end of the track. And you also, of course, need to do something with your sensor here because it's too low. So what you do is you can open this up like so, and then turn it on its side like that. And now the sensor is pointed down the track and you'll be able to get data that way. So you can just move it back here and then as normal, start your cart at least 15 centimeters away from the sensor window, release, and capture that motion using the acceleration program. So that's fairly straightforward. One thing that is not straightforward is you need one more quantity in order to get your theoretical value for the acceleration for this case, and that is you need the angle of the track. So to get that, we've got this little gizmo, this device. You sit it on your track, and then you can read off what the angle of the track is. The uncertainty will be a little bit high, the percent uncertainty, so you do your best to get a good angle value and to get a good uncertainty for it. And the prelab and also tells you how you would get then the uncertainty on the final answer, so on your final acceleration.